In chapter 13.2, we're going to discuss the difference between saturated, unsaturated, and supersaturated solutions. When we use the term solubility, what we mean is most gaseous and solid solutes will dissolve only to a certain extent in a given liquid solvent at a given temperature. A really good example of this is how we make sweet tea in the South. At room temperature, there's only so much sugar that can be dissolved in water. So what do we do to make more sugar dissolve? Well, we heat up the solution. So an example of this in chemistry-wise is the solubility of boric acid in water at 30 degrees Celsius is 6.35 grams per 100 grams of water. So what we mean there is at 30 degrees Celsius, we can only get 6.35 grams to dissolve in 100 grams of water. If we add 7 grams, well then only 6.35 grams of that boric acid will dissolve, but the rest of it will just be a solid at the bottom. We can't get any more to dissolve. So a solution that contains the maximum amount of dissolved solute at a given temperature is said to be saturated. So if I had 6.35 grams per 100 grams of water at 30 degrees, then it would be considered saturated. If the solution contains less than the maximum amount of solute, it is now unsaturated. So let's say I added only 3 grams of boric acid to 100 grams of water at 30 degrees Celsius. Well, technically we could add more boric acid to dissolve. That would be considered unsaturated. Here's a figure that shows how increasing temperature will cause the solubility of certain solids to increase and rarely, sometimes even decrease. So this solubility is how much in 100 grams of water. Let's look at table sugar. So in 100 grams of water at 0 degrees Celsius, so at freezing, we can get 180 grams to dissolve. If we increase the temperature all the way up to about 40, we can get 200 or maybe even 35 degrees Celsius. We can get 240 grams to dissolve. So that tells us that increasing the temperature will also increase the solubility for table sugar. Another good example of this is KNO3. So at 0 degrees, we can only get maybe 18 grams to dissolve, but if we increase it to 100 degrees Celsius, we can get 240 grams to dissolve. So it's a very common trend that increasing the temperature will increase the solubility. However, there are very specific cases where this doesn't happen, and that would be SO2. Increasing the temperature did not increase the solubility, or even NH3. So this is not always the case, but most of the time this is the case. So the solubility of most solids in water increases with increasing temperature. So it's not all, but most. If you lower the temperature of a saturated solution, the solution now holds more solute than is stable, forming a temporary supersaturated solution. So an example of a supersaturated solution is A. We don't have the details yet, but for instance, let's say we've added a lot of sugar to the solution, and it's well over it's well over saturation, and we've heated it up so we can add even more. As it comes back down to room temperature, it's still homogeneous, it's still dissolved. So at that temperature, we have more dissolved than normal saturation. So that's why it's called supersaturation. But eventually, as it comes back down to lower temperatures, it'll recrystallize. That's an example of B and C. When it recrystallizes, it's turning back into a solid. So whatever can be dissolved or is saturated is still going to be dissolved, but everything else is going back to a solid state. So in these two solutions, if I was to ask what is this unsaturated, saturated, or supersaturated, if it's recrystallized, it is now just saturated. If it is dissolved but has more than the saturation level, that is when it's supersaturated, and it has to be homogeneous. And that's when a lot of students make mistakes right here. Because if I add too much and it recrystallizes, now it's just saturated. Example 3.2 says the solubility of sodium acetate in 100 grams of water is 119 grams at 0 degrees Celsius and 170 grams at 100 degrees Celsius. So this one's going to ask a lot of different steps, and we have to answer them. If 170 grams of sodium acetate is placed in 100 grams of water at 0 degrees Celsius, because temperature is very, very important, how much will dissolve? Well, at 0 degrees, only 119 grams will dissolve. Whatever is left over will just be a solid that's just at the bottom of the beaker or whatever you're trying to dissolve it in, but only 119 will be able to dissolve. Is the resulting system homogeneous or heterogeneous? So homogeneous means that everything is dissolved, and heterogeneous means that there's still solid left over. So because this solution is going to have 119 grams dissolved in the water, there's going to have leftover solid sodium acetate at the bottom of the beaker. So 170 grams minus 119 is going to be 51 grams of sodium acetate that's going to be left over as a solid. So because of that, this will be a heterogeneous solution. And then part C, is the solution saturated, unsaturated, or supersaturated? So it's important to know the difference. If it's at saturation, meaning there's no more that can be dissolved, then it's considered saturated. If there's still room for more to be dissolved, it's unsaturated. And then if it has more than the saturation level and it's homogeneous, then it's supersaturated. So because we're at the maximum capacity, this solution will just be saturated, because 119 grams was dissolved at 0 degrees Celsius.